I'm looking forward to the play. If I am capable by then of, if by then I'm capable of standing for a long time, then I will go see the play. Last night I had something happen to me. I swear God has a sense of humor, sense of irony. I was walking Ziva last night, and I got to a point in the walk where she was smelling an area, and I was standing there. And the hardest thing since the surgery tends to be when I'm standing. When I'm walking, I feel fine. And nothing hurt. My knees were fine, my ankles, my hips, everything was fine. Nothing hurt on my entire body. And I stood there and I realized that for as far back as I can remember, nothing hurt. And I smiled to myself and I said, this is it. This is it. I made it. I'm here. Nothing hurts. And then I walked about 20 feet, it was in the dark. I walked about 20 feet and someone had laid a wire across a field I was walking. And I trip on the wire. And you ever do that, like you trip on a wire and you gotta take like 7 fuddy steps to not fall? And I got my hip, my ankle, my knees didn't hurt. But my hip hurt, my ankle hurt, and everything else hurt. And I had to walk about a mile home or 3/4 of a mile home with the dog. And I'm like, oh. So yeah, so anyway, I'm like, this is my moment of no pain since 7 years old. And I walk 20 feet and I'm in pain again. So who knows how it's all going to shake itself out. I couldn't help but giggle to myself. Okay, number 1 says solve for x. When the directions tell you solve for x, what are you thinking to yourself?
Get x equals.
X equals or get x by itself. Very good. Okay, Leanne, I would swear that you give these answers on purpose. Because you watch her take her quizzes, and she usually rocks, and her tests she usually does really well on too. And she comes up with some answers in class where you're like, are you blonde? I mean, what is going on here? And I'm allowed to say that because I married a blonde. Do you realize that there are no blonde? Well, Sid's kind of a little blondish. A little. You're kind of like what they call dirty blonde. Oh, Mia! Oh, Mia was hiding behind Catherine. Yeah, Mia's blonde mixed with green, blonde mixed with pink, blonde mixed with purple, whatever the color of the day is. All right, so I'm going to put this over 1 and cross. Wow, I'm not going to do that. I'm going to put this over 1 and cross multiply. I'm just going to put this over 1 and cross multiply. So 3ax plus 2b equals 4cd. Does it make a difference if you write 4DC?
No.
Why?
Because the computer didn't copy.
Oh, that's good. That's good. Very nicely said. Okay. Subtract 2b. You get an extra star for that.
I studied.
There you go. You do work hard.
How do you study math?
You do it.
Yeah, but
You just do it and get to work.
different numbers, then there's no point.
No, because
There's
there's
a
a
point.
process and a procedure. For instance, listen, you take out one window. Not every window is the same size. They all have different measurements. But when you learn the skill behind taking out a window, you can do subsequent windows. So when you learn the skill of solving for one variable with situations, you should be able to do it with other variables. So 3ax equals 4cd minus 3b. I need to get x by itself, so I got to divide by 3a. Divide by 3a. And I get 4cd minus 2b over 3a. Okay? Any questions? We're good? Go ahead. I didn't divide by 1. I set up a cross multiply.
Wait, how do you
Wait,
set
then
up a
what
cross
line?
multiply?
I mean, I put it over 1 just so I could cross multiply.
Wait, move your hand.
It's a little bit off kilter, but like if I wrote this, 2
Oh,
over 3
just
equals
joking.
5 over a, you would know how to cross multiply, right?
Yeah.
So I put the over 1 so I could cross multiply. So I did 3ax plus 2b times 1, which is just 3ax plus 2b, right? Yeah, so that I could cross multiply. Now, I could have just multiplied both sides by c. I just think kids see cross multiplying better. Okay? Any other questions? Okay. Next up. Now, I want you to notice something about fonts. Do you know what a font is?
Yeah.
Yes.
Right, like this is a font off my computer. This is a font off my computer. This is not. When you see a font that's not on my computer, then that means I went somewhere to get that question. This question was given to us by the state of New York. And they gave it to us in a packet of materials meant to give to you for the Common Core. So whenever you see a question like this, I would say to yourself, hey, this is the kind of thing the Common Core wants emphasized. Now, some of the stuff like this is over the top, and you'll never see it on the test. This one is very reasonable. But it's always designed to get you to think deeper. That's the biggest thing about the Common Core. They want less material, less width, if you will, and more depth. Now, the sum of two numbers is 25. What are these numbers? At first, you look at it and you say to yourself, I have no clue. I don't even know how to begin to do that. But if you look at letter A, it says create an equation using two variables to represent this. So it's x plus y equals 25. There's my two variables. Okay? Two variables whose sum is 25. And then it says create an equation. I did that. And then it says explain each variable. So I could say x is the first variable and y is the second variable. If I'm graphing it, I could say input, and what would the other one be? Output, good. Now, list at least 6 solutions. Now, it's interesting to me that they asked this, because you don't ever really have to graph this. What are 6 solutions that work out so that x plus y is 25? Go ahead. 24 and 1, good. What's another one? 11.5. How many variables? List, blonde, sorry, the blonde moment. List 2 variables.
11 and 11.
What?
And that sum is 25. Lily? 20 and 5, good. What's another combo? Wyatt? 19 plus 6.
1 plus 24.
Which they, before they said 24 and 1, but 1 and 24 is kind of different. Mine? 13, 12. Okay, Lily?
18 plus 7.
18 and 7. Would you like to try to redeem yourself?
10 plus
15, very good. Okay, we already said that one, but that worked. All right, so those are combinations that add up to 25. I want you to notice something. Once you saw this question, with the exception of Leanne, wasn't it easy for every person in the room?
Yeah.
Very good. So Common Core does not necessarily mean harder. I like to think of Common Core as everything is off. You ever have a dog that when the dog looks at something or hears something, they normally look at you normal, but every once in a while they do this? You ever see them do that? You ever see the dog kind of tilt their head to the
And then they
side?
like put their ears up.
Right. So yeah, you can see the facial expressions like, let me think about what this is. When I see Common Core font like this, I want to go, and just think it through a little bit. It's not necessarily harder, but it's just a little weirder than we're used to. But once you see it, it rocks. It's not, for the most part, it's not that difficult. Okay. Now, let's get to today's lesson. Okay, I would like you to solve this graphically. Do this first. You don't need my help for this. And then we'll talk about the algebraic solution in a minute. Go ahead. Well, we're doing in the next page, there's a graphic and an algebraic. You're doing the graphic only, okay? Okay, so I think everybody will have done the red line perfectly, right? Pretty straightforward, you don't really have anything to do. We might have a couple of mistakes with the blue line.
Yeah.
A couple of different ways to do this. I really don't like that minus y. Now, how many people subtracted the x first? How many people added y first? I like adding y. I think adding y is better, but more people did subtract the x, so I'm going to do that, and then I'll go back and do it the other way. Subtract the x, and here's the danger part, right? That y is negative, so I have to write negative y equals negative x plus 7. I could write 7 minus x, but I want that mx plus b format. And then I have to divide everything by negative 1, and I get y equals x minus 7. Okay? So that means that I'm going to go down, well, actually, let me also do it this way, ready? X minus y equals 7. This, to me, is the easiest way. Add y to both sides, and then I get x equals y plus 7, and then I'll minus 7 from both sides. And I get x minus 7 equals y. The reason I like that is because I don't have to deal with negative signs. Look, I've been a student for as long as you've been a student, and then some. And then as a teacher, I've been a teacher for 30 years. Plus, I went through college and got a math degree. And when I look at a question like this, or a way of doing it like this first way here, I am constantly looking at afterwards to see if I might have made a mistake somewhere. But if I do it this way, I don't look at it. I just see right away that everything's positive and we're working it out. Okay, so I begin by touching at negative 7. 1, 2, 3, 4, 5, 6, 7, and then it's up 1 over 1. And I want to say here, it looks to me like it's going to meet down there. Okay. I don't know off the top of my head what that coordinate is.
It's gonna be 11 if it goes down 10.
I think it's going to be negative 6 it meets at, and if it's negative 6, it's going to be negative 13. I think it meets at negative 6, negative 13. Now, this is very interesting. Listen, how many people, as you looked at this problem, can see the red line graph, say, okay, that makes sense. You know, maybe not quite as quick, but you can see the blue line graph, okay, that makes sense. And when it comes to finding the solution, you're saying to yourself, it's kind of off the graph, it's kind of down there a ways. I'm kind of getting this hinky feeling about looking at that. Anybody feel like that?
Yes.
Yeah, I feel like that, right? Like I'm not exactly sure that it's negative 13. So because of that, sometimes it's better to do things algebraically. Notice this is a Common Core font. And what the Common Core is getting at with this question here is they're saying, look, sometimes you're better off doing it algebraically. So let's take the same two equations and let's start solving it algebraically. Now, yesterday, we did work using what we call the elimination method, right?
Yes.
All right. Now, there's a problem here with the elimination method. Do you notice how things don't line up right above each other and below each other?
Yes.
Yeah. So I'm going to have to rearrange this a little bit so that I get everything above each other, which means, can you see if I could put the x's over here? I'd have x, y number, and then x, y number. Can you see that? So what I'm going to do is go over here and manipulate a little bit. This is 2x plus 1, and then I'm going to subtract 2x from both sides, and I'm going to get negative 2x plus y equals 1. Does everybody agree with that? And then I have my second one, which is x minus y equals 7. Now, do I have opposite signs here?
Yeah.
And the numbers match up. So do I have to multiply like least common denominator? No. So I'm just going to add. This is negative x equals, 6. So I divide by negative 1, and I get x is negative 6. And that makes me feel good.
How is 6?
Oh, I'm sorry, I'm adding. It's 8. So, well, there you go. That just shows before that just shows you that before I couldn't read the graph right. Remember we said sometimes it's off the graph and you have a hard time with it? So it's there, yes.
How come you did y minus 2x, then you wrote negative 2x?
Well, first off, does it make a difference if I write y minus 2x or negative 2x plus y? No, it's the same thing, agree?
So you just,
So I did it this way, that way I'd have my x's, y's, and numbers in the same order. Okay? Now, x is equal to negative 8. So that means that it wouldn't fit on the graph before. I ran out of space and I tried to eyeball it, but I didn't get it. So this is clearly a situation where the algebraic is the best technique. Now let's go back and plug the x in here. So I get y equals 2x plus 1, and y is going to equal 2 times negative 8 plus 1. So y equals negative 16 plus 1, which is negative 15. So what were the coordinates where the two graphs should have crossed? Negative 8, negative 15. Good. Okay? So sometimes the algebraic way is an advantage. Look, most of the time when I do it graphically, they meet at a perfect point right there, and everybody's like, oh, that's so easy. But sometimes it gets ugly. And to have another skill to complement graphing for when it gets ugly is an important thing to do. So this is the algebraic way, it's the elimination method. The thing I want you to remember about the elimination method is this. The only way to do the elimination method, and that's the only method I've shown you so far, is you must get the x's, the y's, or one letter, then the other letter, then the numbers. It originally didn't look like that, so you need to manipulate the equation a little bit until you get it to look like that. Is there any question about that? Okay, so now we've finished out everything we need to do for the period. So you can get started on the homework, but if I were you, I would look for the algebraic simultaneous solution question, knock that out first. If you have any questions, you can bring it up to me or talk to the person you're sitting with. You know, don't do the ones you can do in your sleep. Let's get the other ones done and taken care of.